In this video, I just want to talk about this idea of shifting indices in a summation. So if I have the sum from n equals 0 to infinity of a sub n, we know that what this means is a sub 0 plus a sub 1 plus a sub 2 plus, and so on. And of course, when we write this down, we're thinking that this term corresponds to when n equals 0, and this term corresponds to n equals 1, and this one corresponds to n equals 2, and so on. But what if we have exactly the same sum, but we imagine the n values differently? So what if I tell myself, well, I can write 0 as 1 minus 1, and I can write 1 as 2 minus 1, and I can write 2 as 3 minus 1. And I imagine that this is n equals 1, this is n equals 2, and this is n equals 3. Well, then I can write this summation as the sum starting at n equals 1, going to infinity, and now my term is a sub n minus 1. I can do this any way I choose. So let's say I have the same summation, a0 plus a1 plus a2, and for some reason I want my summation to start with n equals 7. So this is going to be n equals 7, this is n equals 8, this is n equals 9, and so on. Well, then I have to figure out how to write these subscripts in terms of that value n. So we know 0 is 7 minus 7. We know 1 is 8 minus 7. We know 2 is 9 minus 7. And so we can write our summation starting at n equals 7, going up to infinity, and my term is a sub n minus 7. Let's look at these examples and see what pattern we notice. So in our original summation, we had n starting at 0. In our first change, n moved to 1. At the same time, we had n as a subscript in our term in the first summation, and n minus 1 as a subscript in our new one. So the value n started at, from 0 to 1, we added 1. And where we see an n in our term, we replaced n by n minus 1, so we subtracted 1. Similarly, if we compare our original sum to the one that I've written in blue, in our original, n started at 0, and then our new one, n starts at 7, so we have added 7 to that number. In our original term, we had the expression n, and in our new term, we have the expression n minus 7. We have subtracted 7 from each n that appears in our term. Now let's look at a couple examples where this might be useful. In our first example, we have the sum from n equals 5 to infinity of the fraction 3 divided by n minus 4 to the 4th power. I'm noticing that the expression n minus 4 here might not be so easy to deal with. So I would like to rewrite this as the sum of 3 divided by n to the 4th power. The point here is that I've taken n minus 4 and changed it into n. And so in effect, I've added 4 everywhere I see an n in the expression for my term. That means that when I'm deciding which term to start with, I need to subtract 4 from the starting index. So instead of n starting at 5, n will start at 1 and go up to infinity. If we want to check and make sure this works out, we can write out the first couple of terms. In our original sum, the first term is n equals 5, and our term is 3 divided by 5 minus 4 to the 4th. Our second term would be n equals 6, and we would have 3 divided by 6 minus 4 to the 4th power, and so on. In our new summation, our first term is n equals 1, and our term is 3 divided by n to the 4th, so we have 3 divided by 1 to the 4th. Our second term, n equals 2, gives us 3 divided by 2 to the 4th, and so on. And we can see that these two expressions are indeed the same. Let's look at this example. I have the sum from k equals 1 to infinity of x to the power 2k plus 10 divided by k plus 5 factorial. What I am observing is that we have k plus 5 in the denominator, and if we factor out a 2 in this exponent, we have 2 times the quantity k plus 5. So it might be desirable to eliminate the k plus 5 in those two places and instead have just k in each of those places. So I would like to have a sum where my exponent on x is 2k, and in the denominator I have k factorial. So I have replaced all the k's here by k minus 5. So I've subtracted 5 from each k in the expression for my term. So in my original sum, when my first term corresponds to k equals 1, I need to add 5 to that index for my new sum. So my new sum starts at the index k equals 6 and goes to infinity. Again, we can write out a couple of terms just to make sure that this is okay. So if k equals 1 in our original sum, we have x to the power 2 times 1 plus 10 divided by 1 plus 5 factorial. Our second term, when k equals 2, gives us x to the power 2 times 2 plus 10 divided by 2 plus 5 factorial, and so on. In our new summation, our first term corresponds to the index k equals 6. Our exponent on x will be 2 times 6. In the denominator, we have 6 factorial. And our second term corresponds to k equals 7. So we have x to the 2 times 7 divided by 7 factorial, and so on. If you look at these two expressions that I've written down in green, you will notice that they are equal.